Good afternoon, Senior 5. I hope you are well. This is what I had prepared to teach you this afternoon, though you didn't turn up. You remember the other time we looked at the trigonometric identities. We looked at the expansion for cosine, the one for sine, the one for tan, like that. And you also remember that we saw special angles. So we can have questions where they say you find the values of some identity, like that one, cos 45 minus 30, without using tables or calculators. Now what you do in this case, you expand this. You remember that cos A minus B, if this one is minus, then you use the ratio for subtraction of cos. You remember that cos A minus B is equal to cos A cos B plus sin A sin B. These identities, we looked at them and I hope you remember. But now, where there is A, instead we are having there 45, and where there is B, we are having there 30. So what we are going to have here, it will mean that cos A minus B, if it is equal to that, then cos of 45 minus 30, where there is A, we put there 45, and where there is B, we put there 30. So cos of 45 minus 30 is the same as cos 45, then cos 30 plus sin 45 sin 30. Now, remember the question said we should not use calculators. So what we do in this case, we go to our special angles. We looked at those ones when it was our first lesson. I hope you remember. So special angles, I've tried to draw these triangles here to remind you. The special angle for cos 45, according to this triangle here, cos 45 is adjacent out of hypotenuse, so it is 1 out of root 2. Then cos 30 is adjacent, which is root 3 out of 2. I think that is not a problem to you. So finally, cos 45 minus 30 will be equal to cos 45, which is 1 out of root 2, times cos 30, which is root 3 out of 2, plus sin 45, which is 1 out of root 2, then times sin 30, which is 1 out of 2, which is a half, and we simplify. So when we multiply 2 times root 2 here, the answer is 2 root 2, and 1 times root 3, the answer is root 3, as you can see. Then what remains there is just mathematics. The LCM is the same, so we have 2 root 2, and the numerator is 1 plus root 3. Then we rationalize by multiplying up and down by 2 root 2, and we end up having this one as our answer. 2 times 2 is 4, and root 2 times root 2 is 2. So 4 times 2 is 8. That's how it comes about. So that's how we can simplify that when we are using special angles and ratios and trigonometric ratios. Now, if you have something like cos 105, you see in the special angles we have 60, we have 30, we have 45, but 105 is not there. So you try to find the values from these special angles of 60, 30, and 45. Which one can give you 105? And I'm saying it is 60 plus 45. Then you expand this. It will give you cos 60 cos 45 minus sin 60 sin 45. And here we are. we put the special angles. Cos 60 is a half, that is it, minus sin 60, it is opposite root 3 out of 2, and cos and sin 45 is 1 out of root 2, and we simplify in the same way, and when we do that we end up with this one as our answer. Now, having understood that, you are going to do for me this work without using tables or calculators. You evaluate cos 45. Now, I mean 75. Now, 75 can be obtained by saying it is cos. Let me give you a hint there by saying it is cos 30 plus 45. Cos 45 plus 30, that is 75. 45 plus 30. Then 15, it is 45 minus 30, like that, don't forget. Then if you have sin A equal to 3 out of 5, sin B is equal to, that means they want you to get sin A plus B. Now to get sin A plus B, if you need cos A, you are going to first draw triangle. By the way, in this case, first draw a right angled triangle. You see, sin is positive. Sin is positive, so it can be in the first quadrant. So this one becomes angle A. Sin is opposite, so this is 3 and this is 5. Then you get the value of adjacent here by calling it x, and I think it will be equal to 4. Meaning that cos A will be something like adjacent of hypotenuse will be 4 out of 5, like that. So that's how you are supposed to approach that. Then when you get the value of sin A plus B, and we get the value of cos A plus B, to get cot, you know cot is cos out of sin, so you should do that one. Here they are telling you that A is obtuse. Obtuse is greater than 90, so it means A is an angle which is greater than 90. B is acute, and so B is acute and A is obtuse, meaning A is, this one is in the second quadrant, then B is acute, it is in the first quadrant. And remember, in the second quadrant, only sign is positive, so the value you get for cos theta, for cos A, it should be what? It should be negative. Take note of that. Yes. Let me show you another example. I have another example here. We are saying, given that sin x plus 45 is equal to 2 cos x plus 45, then we want you to find the value of tan x. I'm saying you can first open, and you know how we open. It will be sin x cos 45 plus sin 45 cos x. I think expanding should not be a problem to you now. You can first write the identity of sin A plus B, then where there is A, you put there x, and where there is B, you put there 45. Then when you expand this, you get cos x cos 45 minus sin x sin 45. I think you have no problem with that. Then the special angles for sin 45, I'm saying it is 1 out of root 2. The special angle for sin 45 is 1 out of root 2. Then when we put in the special angles, we can collect like terms. This 2 sine x times 1 out of root 2, which is the same as root 2 out of 2, it can come to find this sine x, and that's what I have done here. Then I take this across, it becomes a negative. That's why it becomes 2 cos x out of 2, this one, minus 1 out of root 2 cos x. Now the denominator is the same, so I will just have 2 cos x minus cos x, and it is cos x. Then this side I will have sin x plus 2 sin x, which is 3 sin x out of root 2. Now I can multiply by root 2 on both sides, by root 2, which will cancel here, and I have 3 sin x equal to cos x. But the question was saying that you find the value of tan x. So to get tan x, I will divide by cos both sides, and sine out of cos is tan x. So that means tan x, 3 tan x is 1, and tan x alone will be a third. That's how you can approach those numbers. And I'm sure by putting in the special angles and expanding, you'll be able to get the values of these angles. That's all.